Okay. Today's object is a planetary nebula called the Spirograph Nebula, or IC418, or the Raspberry Nebula, or the Colored Context Nebula. That's probably a fairly new term for it. A planetary nebula is called a planetary nebula because when the first people were looking through telescopes and finding things, it looked like a planet. It just looks like a fuzzy ball. A lot of them do. What they actually are is the or what do you call it, death stage? Because they're considered white dwarfs afterwards, but there's just still another type of star. But it's leaving the main sequence of stars at this point. What happens is a star collapses onto itself in the beginning, and if it's a star, it will start fusing hydrogen, and then it will expand out until an equilibrium point is reached, and then once the hydrogen is done, it will. There's not enough the energy. There's no energy from the hydrogen, so the gravity squeezes it back in, and then helium is fused, and that energy makes it expand out to another equilibrium point. Like for the sun, when it gets to this point, it'll probably become the size of Mars' orbit, which is about where will be inside of it. And this will happen in 4.5 billion years. After that, after that, if there's enough mass in the sun, it'll burn like carbon and oxygen. And then the energy from then the gravitational force pushing the star inward won't be enough to create pressure enough to create more fusion, so the heat will just push off the outer layers of the sun into deep space. And why it glows so far away from the sun is because the core of the sun, or the star, gives off ultraviolet light, which is about 10,000 to 40,000 Kelvin. And those photons will excite the electrons in the dust and gas, and excite them, and then they'll go back to a lower orbit inside their atoms and give off light. The different patterns, planetary nebula have different patterns. This one's actually a fairly round one, but it does have like a spirograph pattern, if you remember the old toy from the 80s. That's probably due from the stellar winds. Like all stars push out particles from them. That's called a stellar wind or a solar wind. But there also could be like the magnetic field of the star could affect the shape, or if there's a binary star in the system. And a couple of things to look out for this week. This is located in the constellation Lupus, which is underneath the constellation Orion. This actually wasn't the original object I was going to do, but the original object is labeled in this program differently. But you can see it's right underneath between Rigel and Sepa. Okay, here's the thing about star names. They're usually Arabic. There's a reason for this, because the Greeks named the constellations in the brightest planets, and then for a while a lot of knowledge and learning was done through the Arabs, while Europe was in the Dark Ages. So they named a lot of the stars. So that's why you have stars like Rigel and Betelgeuse. A lot of stars have the letters AL, I think, which means the in Arabic. But also another couple things to keep. Later this week, on the 13th and 14th, there is the lunar eclipse. I think it peaks about 3 a.m. Atlantic time, or about 2 a.m. Eastern time. That's when the Earth passes in front of between the sun and the moon. And also at the end of the month, on the 29th, there's a partial solar eclipse that will be visible from the Maritimes. This is, it'll look like some people have described it as a set of horns coming up from the east. But if you have clear skies it'll be at very early morning, just as the sun rises. So keep an eye out for that. I think there's a couple organizations that are doing gatherings. I think there's one in St. Andrews, which is a nearby town to me. But I hope you have found this a little bit useful, and have a good day. And see you later. Bye. Have a good one.